Hi friends, so today I want to talk about ESP32 and Raspberry Pi Pico, how we can use these two together to control HUB75 matrix display. So I have two with me. One is 64x64 2.5p pixel pitch. Like if we join these two together, so then it will become like 128 by 64. How we can use ESP32 and Raspberry Pi Pico, so both together to control this as a master-slave architecture. Why I want to use a master-slave architecture? Even I can use it ESP32 or Raspberry Pi Pico alone to control the matrix display. The problem if we use only one, either ESP32 or Raspberry Pi Pico, it has to do two tasks. One is it has to run business logic where it has to prepare the content what we want to display on the display. Like for example, if we want to display some text, so where we are using some fonts and giving some text to render the text on the screen, the fonts to be converted into pixel data, and if we want to display any image, then reading the image data and converting into the pixel map, so that part. And at the same time, if we want to switch the program dynamically, if we use the ESP32, it has the Wi-Fi, we can use the Wi-Fi to control the program. Suppose if we want to change the program, if we want to send some text from the mobile app, or if we want to switch the program, we will be using the Wi-Fi. So then the CPU has to run Wi-Fi tasks and as well as rendering of the text or content, and then it has to run the frame buffer to the matrix display. All together become like more burden to the single CPU. And when we use the only ESP32 or when we use only Raspberry Pi Pico to do all these tasks, running the application logic and driving the panel, both together the panel refresh rate will reduce. Then you will see some flicker on the panel, or you will see some noise on the panel, and you don't see some smooth text like when you want to run some animations like scrolling text or some transitions while changing the image or while changing the frame or while changing the page. So you will see some flickers. You don't see like proper color, and you also see some noise. To avoid that one, I can use two together. One is ESP32, since it has the Wi-Fi and it has the Bluetooth and it has the 2-core CPU and it has the DMA support. By considering these features, I will use this as a master controller where I can connect this from my mobile app and run some text or control my app UI, so that I can use perfectly this one. Then I can offload rendering logic, driving logic of the panel. So like where this panel continuously refresh, like for example 120 Hz or 280 Hz or 60 Hz, whatever the refresh rate that we want to drive, that process I can offload from ESP32. Then that logic I will put into Raspberry Pi Pico. It will not make any burden to the ESP32, so where it is not directly driving the panel. So now let us talk about the what Pico will do. The Raspberry Pi Pico, since it doesn't have any Wi-Fi, we can use efficiently only rendering the panel. It has the two buffers, so that's called the dual buffer. Each buffer, it has all the pixel data what to be displayed on the panel. So that buffer will be keep on refreshing on the panel. So that is done by Raspberry Pi Pico. So it won't do anything. It doesn't know about Wi-Fi logic. It doesn't know about your application logic. It doesn't know about your fonts. It doesn't know about your images, anything. It has only task that it has to keep refreshing the panel so that it can do efficiently, because it doesn't have any other work to do. Its CPU will be utilized properly and its PIO interface utilized properly to do these tasks. So the communication between these two, I want to establish SPI interface, and ESP32 prepares the final frame buffer what to be displayed on the screen. Then it sends to the Raspberry Pi Pico over SPI interface, so that whenever Pico receives the SPI interface frame buffer, then it updates the back buffer. Then once it updates the back buffer completely, then it swaps the buffer, so which means that the front buffer will be updated from the back buffer. So immediately you see the updated text or updated content on the panel. So there won't be any interruption, or there won't be any flicker, there won't be any noise on the panel. So because we are keeping two workers to do their own job, so instead of giving a lot of work to one person, if you put two persons and split the work, then the work will be done efficiently. So that's how I designed this solution. Like ESP32 is the master controller where application logic will be controlled, and the Raspberry Pi Pico is slave, or I would say like dedicated panel driver. It keeps refreshing the panel so that the panel will give the solid UI. So it won't be any flicker or it won't be any noise. Without waiting, so let us start how it works. I have made ESP32 breakout board. Why I don't want to directly solder this board on generic PCB, because I don't want to use ESP32 board only for this project. If I want to use this board for some another project, I should be able to use it. If I directly solder on top of this general purpose PCB, then I cannot use it. So this will be fixing for this project. So that's where I made breakout board kind of thing. So where I can insert my board, then if I do want to use for some another purpose, I can remove it. It becomes dedicated master controller for my project. Similarly, I have made another breakout board for my HUB75 connectors. I can insert Raspberry Pi Pico board to this socket, then this will become my HUB75 panel driver. Now my ESP32 controller ready, and my Raspberry Pi Pico panel driver is ready. Now the master controller and then HUB75 panel driver to first panel to second panel. The first panel out will go to the second panel in. First panel out and then second panel in. So the power source is going to, I have 5 volts power source. So where I can connect this wire, then I can power up these two panels independently. Like this is the first panel power and this is the second panel power. So I have two projects. So one is HUB75 Master Controller. So this is the master controller project that I am going to load into ESP32 board. Then there is another project, Pico panel driver. Both have configuration. Width is 128 and panel height is 64. If we see here, ESP30 software, that is 75 master controller. It also has 128 by 64. So now let us deploy this one into the board. Since I am using the platform IO, I will run like PIO run. Target is upload. It is connecting. Yeah, it got uploaded 100%. Now our master controller is ready with the software. So I am going to switch this one to PIO. PIO run P upload. Let us see. Yes, success. So now I have uploaded master controller software and as well as panel driver software. So now it is time to connect panels. I have connected the power, so power to the panels, and I have also connected the data connection to the panel. So I have connected my SPI bus to the ESP32. So let me power up the ESP32. See, that is restaurant menu style board I have made. I have also applied the animations. Each page will get like each title animated from bottom to top, and each page. So let me change the program. So I will render one more program, like that is clock. Now I will comment menu program. So I will enable the clock one. So and here also I don't need this test loop. So here also I don't need this menu. So in my loop I have menu items commented. So clock display is updated. So draw time with seconds. So what will be drawn? So let us see. So I'm going to upload my software. Yeah, it is 100% updated. See, the clock is coming. So let me change the clock style. So I will apply another style of clock, like yeah, it is 100% updated. So now you see like blinking clock. So now let me change one more style. Draw date and time. Yeah, now you see the date and time is coming. Whenever we want to change the program, we want to reload the program again to the board. Instead of that, we can connect board to a mobile app. From mobile app, we can change the programs. Any program that we want to change, we can control from the mobile app.